Welcome, everyone, to Puppet Camp Duesseldorf. Thank you all for coming. I'm Dawn Foster. I work at Puppet Labs. I'm the community lead at Puppet Labs. And I wanted to especially thank NETWAYS for organizing the camp. So the reality is that they do all the hard work to organize it. So I just wanted to thank them for being our organizing sponsor. And the other quick announcement I wanted to make is that we have announced the date for our next Puppet Camp in Germany. So the next one is going to be Puppet Camp Berlin, and that will be on April 24th. It's going to be right after the OSDC conference. So NETWAYS, again, is our organizing sponsor for that one as well. So I wanted to just thank NETWAYS. Thanks. And we have a full schedule for the whole day. So with that, I'm going to just turn it over to Luke Kanies, Puppet Labs CEO, and he's going to do our Puppet intro.
Good morning. So I'm the founder and CEO of Puppet Labs, and I'm also the original author of Puppet. They don't allow me to write code on it anymore, but they're actively trying to change it all to languages that I can't even write. So, but I'm going to talk a little bit about Puppet, and this is a relatively introductory talk. We used to throw these camps directly into the beginning with lots of relatively deep technical talk, and it turns out about half the people who come to these are usually brand new to Puppet. So try to do a basic intro. And speaking of that, actually, I just want to do a quick poll so I understand what the audience looks like. I can go faster or slower through some sections based on who's here. So who here is using Puppet already right now? All right, and who is using some other automation tool? What about something that you wrote yourself? Who's using automation but only like hand-rolled shell scripts, Perl scripts, Erlang scripts? All right, and who is not using any automation today in their systems? All right, that'll end by the end of the day. And who's new to Puppet at least? Because it looked like about half the room was already using Puppet. All right, so we've still got a good bit of beginner stuff. All right, so hopefully it'll work well. So this is we do a pretty similar talk at the beginning of these, but we just rewrote the whole thing. So this is you get to be our test audience for this. So I think there's a lot of really interesting things going on in the world of infrastructure right now. I think there's a lot of complicated things, a lot of really big changes that are happening that are affecting anybody who works in systems and really anybody who works in development. And the reality is, being a sysadmin itself is a pretty hard and tedious job on its own. Studies show that on average, sysadmins get interrupted every 15 minutes, and other studies show that it takes about 30 minutes to recover from being interrupted. So if you lead the typical life of a sysadmin, what this means is you literally never get anything done ever. And this shows up in all kinds of, this has a lot of really negative consequences. Obviously, the first one is it sucks to be a sysadmin because you're interrupted all the time, and you kind of stand there all the time waiting for the bad things to happen. But the worst thing is that you don't get to do the things that really matter to your business. Instead of being able to spend your time focused on the interesting strategic work for your organization, you end up doing very reactive work, very firefighting work, to the point where I've worked with people who the firefighting aspect of the job becomes, it's almost like a junkie experience. Like they're more interested in making new fires so that they can rush over there with their trucks and put them out quickly. And so that's kind of the baseline of the reality of our world of operations. But technology itself is becoming more critical to our customers, to our companies than ever before. We went through this period in the like late 90s and early 2000s where a lot of companies said, well, we're not a technology company, so we're going to outsource our technology to somebody else, and they'll do that and they'll do it for cheaper. What they found was that didn't work very well, because it turns out that everybody's pretty much a technology company anymore. You've got to have, for you, technology has to be a competitive advantage. If you're not good at technology, no matter what your actual job is in the world today, you're going to kind of get your ass handed to you by the market. So what you're seeing is a lot of companies bringing the technology back in, a lot of companies working pretty hard to figure out how do we make sure that we're great at technology and that we're specifically great at technology in a way that's helpful to us as a company, right? So it's not enough to be super geeky and cool. You have to actually align the work you're doing and the technology investments and successes you have with the goals of the business. And in terms of what everyone's trying to do with that technology, the major focus that nearly everyone I talk to is around is how do I move more quickly, and not just higher velocity overall, right? It's not about necessarily doing any given thing faster. It's about how do I accelerate my cycle times? How do I learn faster? And how do I ship my software twice as quickly as my competition? How do I make twice as many changes to my product in the same amount of time as my competition can make? And that allows it doesn't matter what field you're in. It doesn't matter what your business does, what your organization does. If you can evolve more quickly, if you can learn more quickly, you can get a lot more done. Obviously, DevOps is also a pretty major effect in the market right now. And everybody I talk to, whether it's the sysadmins or I was just at DevOps Days in Toronto, and that was the first DevOps Days where I've been where about half the audience was actually developers. So now, for a long time, people thought it was all developers and it was really all operations. And I guess now the movement's changing a bit and it's becoming a lot more dev and ops. But DevOps is all about how do we move from this world where operations is kind of the party of no. Operations' main job is to say, look, I can be as slow as I want because as long as I'm secure and stable, I don't have to do it quickly. I just have to do it successfully. How do we move from that world to a world where operations is really enabling the organization, right? Operations is aligned with the developers. Operations is aligned with the applications team. And we at Puppet Labs did a report earlier this year. We surveyed around 9,400 individuals to try to understand, first, what are you actually doing, right? What are you doing and what do you say you're doing in terms of internal changes, internal actual practices? And then second, is there any correlation between all those things you're doing or all the things you're saying you're doing and how well you work, right? Is there any correlation? Are you better at your job? Are you demonstrably successful in the work you do because of the investments you made in DevOps? And spoiler alert, the answer was hell yes. You're a lot. These things actually really do help people. As an example, people tend to deploy on average 30 times more often if they invest heavily in DevOps. If they have all these specific practices the DevOps report covers than people who don't. And obviously everyone is incredibly tired of talking about the cloud, but there are two areas that I think are still pretty interesting and are actually, I think, going to continue to affect the way we work for a long time. And the first is just you don't have to buy as many servers as you used to, right? In a lot of cases, and what we're finding is specialist use cases in general, and I don't know much about how things like either literally Amazon's EC2 or whether it's an equivalent, how much that's used in Germany, country by country, it seems to vary quite a bit. But in the US, there's quite a lot of people essentially just saying, look, for this category of problem, I don't have to buy servers anymore. I can go and I can burst to EC2. But I actually think it's more interesting what people are doing with SaaS. If you look at I was saying earlier that the attempted outsourcing technology in the early 2000s failed. And the reason I think it failed is because it was this belief that I can just go to the lowest cost provider. I can go find the cheapest company out there and as long as they give me this nice contract and makes lots of promises, then, hey, I'll be fine. That didn't work because you tried to you outsourced at the wrong layer. But if you look at SaaS, if you look at, the typical company in the year 2000, you had to be good at everything. You had to be good at email, you had to be good at websites, you had to be good at file serving, you had to be good at printers, you had to be good at storage, you had to be good at every part of your infrastructure. But if you can outsource your CRM to Salesforce, and you can outsource your HR to Workday, and you can outsource the things that aren't your core competency, right? The things that you don't have to be fantastic at, then that allows you as a company and you as an individual to become far more focused, far more specialized, right? You can get much deeper in your skill set because you're not having to maintain all these other applications that are important, right? I mean, everyone knows these things matter, but there's a difference between it's important that it works and it's your core competency, right? All of us have plumbing in our houses. The plumbing matters. Probably none of us specialize in plumbing. So how do you not have to solve that problem? And the SaaS is kind of restructuring a lot of the way people think about how they invest in technology, because when you invest in Salesforce, they get to specialize and you get to specialize. So it really changes the expectations of all of your jobs, right? It changes. You don't have to know quite as many different things, but the things you do know, you end up having to know a lot better than maybe 15 years ago you would have been asked to know. And then also, there's a lot of, obviously everyone's super excited about Docker today. They aren't quite sure why, but they definitely know it's going to change the world. But it is part of an interesting trend, and Netflix has been talking about I don't think they use the phrase immutable infrastructure, but they've been talking about essentially AMIs and AMI-like things, AMIs and containers as build artifacts for a long time, and this practice of moving from, okay, the average lifetime of a machine is 3 years to the average lifetime of a machine is 3 minutes or 3 hours. And how does that change how you work, right? And obviously, it's not turtles all the way down. At some point, you do still have servers. At some point, you still do have complete running systems. But when you rebuild your development pipelines, when you rebuild how you think about your applications, when you re-architect all your applications to support some pieces that are themselves never updated, how does that change your world, right? How does that change how you work? How does that change both the opportunities you have, the cool, new, interesting things you can do, and then also how are the skills you have today and the abilities you've been developing over the course of your career suddenly annoyingly irrelevant? And then lastly, and in some ways this is my favorite, it used to be that if you were in IT and your application developers would say, hey, I want X or I want Y, you could say no. And then they couldn't do anything about it because you were the ones who owned the silicon, and they just couldn't get a computer. And without a computer, it turns out it's tough to do very much, other than run it in production on your laptop, which I'm sure they've never tried before, right? So these days, though, if we've seen this at a lot of companies, if the IT teams don't learn how to say, yes, I'm going to find a way to enable you, yes, I'm going to find a way to get you what you want, then the developers just go do something else, right? This is what a lot of people who are using EC2, this is what happens is, developers come, the application teams come, and they ask for help, and IT says, well, we can definitely help you in 18 months, and the developers say, well, that's not enough, we need it in, say, 5 minutes. And then they go online and they do something online. They go buy a service, they go do something hosted somewhere, and it's kind of this interesting dynamic because on the one hand, technology, the IT organization provides a really critical function. You actually do need to be secure. Stability matters, compliance matters. There are a lot of important functions the organization provides, but at the same time, you have to find a way to do that while saying yes to the business, right? While saying yes to the organization that is, paying you and things like that. So it's this kind of internal competition. It's this competition with an outside group for really the first time in IT's history. I think and it's changing behavior of the groups quite a bit. And I think it's one of the real reasons why, from the CIO all the way down to the sysadmin, the IT organizations are feeling more pressure and are trying to move a lot more quickly than they ever have before. So that's what we're here to help you do, right? We as a company, when I started the company almost 10 years ago, I started with a few core goals in mind. And one of the main goals was I looked at companies like Google, which in 2003, 2005 really was the hallmark of great operations. They were the ones who actually had the world's best sysadmins working for them. They had fantastic infrastructure. And every time I talked publicly about, here's how bad the world is, there'd be some wag in the audience going, well, we don't have that problem. Well, we don't have that problem. And it's always, yeah, but you work for Google. I get it. You're an exception. But everyone else is actually going through these struggles. So when I started the company, my goal was, how can I take the technology, the skills, the success that Google has, the way that they think about the world, and build technology that not just Google can use, right, but that nearly everybody can use. And so the goal was I wanted to build something that was sufficiently powerful that it could really actually solve real problems for people, but sufficiently simple that nearly everybody could use it. And I think it's a challenging balance to sustain. And so that's what we've been working hard to do. And with Puppet, the goal in Puppet is to define the desired state you want your infrastructure to be in, right? To not focus on the how, not focus on the steps you want to take to get to where you want to be, but really just to say, this is what I want the world to look like. This is how I want the world to be. And then Puppet's job is to make sure that state is true. And crucially, Puppet doesn't just do it one time, right? It's not a one-time action where, okay, on the initial machine build, you've got it set up where when you first install the piece of software, it'll do the job, but then you hand it off to something else. Puppet can maintain a machine from the minute you turn it on, or even before you turn it on. If you're using it in a build process, you can actually use Puppet to build and set up your AMIs, all the way to the very second you turn it off. Puppet has an important role to play in making sure your stupid computers look the way they're supposed to look. I've been on the road for most of the week, and for some reason I woke up this morning first at about 4:30, which I think is nearly bedtime where I live, and also with a scratchy throat. So sorry, I'll be drinking water all day. So this is a simple example of how Puppet's code looks, and this is one of the areas where our slides aren't quite. I would like to have a little more detailed code that talks about, here was what the resources look like. But in Puppet, the code is pretty simple. The idea in Puppet is we have our configuration language looks a lot like a configuration file, right? The goal is to have it not feel much like programming, because most sysadmins aren't developers. And yes, sysadmins are more and more acquiring the tool chain and the practices of development. We're doing change management. We're doing version control, thankfully. 10 years ago, version control was still pretty rare. I still ran into people all the time who were either using RCS or just had, file.1 and 2 and 3 in their home directories. So we are using a lot more of the tools of development, but there is a big difference between development and operations still today. But in Puppet, the language is built all around the resources, and these resources directly translate to things that exist on your machines. These are the packages, the users, groups, files, services, mount points, all the different things you want to manage on a computer. You can describe the state you want those things to be in Puppet, again, in the simple language, and version control it, share it, post it on the internet, things like that. Once you have the way you organize this code, the way you organize these descriptions of how your servers are built are into what we call modules. And these modules are essentially collections of all of the functionality related to a problem that you would see. So if you're going to manage NTP, there's the code to manage NTP. There are the templates you might be using to generate the ntp.conf. NTP is thankfully simple enough that that's about all there is. But in general, you collect all these things together. If you're looking at OpenStack, it's a much larger module. It might be a series of related modules. And these modules, you put them all on the server, and there are a lot of benefits. Puppet's one of the few tools where the server is actually the only thing that has access to all the code. And there are a lot of benefits in the Puppet world for security is one of the main benefits of that. You don't have to, if you have the code for all of your infrastructure on every machine in your infrastructure, then anybody who is able to compromise one of those machines can see how the entirety of your infrastructure is built. In Puppet instead, if one of your individual machines, whether you have 100 or 1,000 or 100,000 machines, gets compromised, all anybody can learn about your infrastructure is what that one machine knows, right? They can learn that one machine's root password. They can learn that one machine's configuration. They can't really learn anything else. It's also, frankly, a lot easier to use, right? You don't have to push your code to hundreds of machines. You only have to push your code to 1 or 5, depending on how broadly scaled you are. So it's a lot simpler, a lot more powerful. There's a basic node cycle that goes on every time Puppet runs. Every time Puppet wakes up, we go through this basic cycle of communication between the client and the server. And this cycle is important because it's how the central server and the individual agents are all aware of each other, right? It's how, so the first thing that happens is the client wakes up and pulls down all of its plugins, essentially updates all of its code so that it knows it's running the most recent versions of everything. And then it sends a data packet to the server that says, here's everything I know about myself, right? Here are all my facts. And those facts are very extensible. It's one of the first places where people who are using Puppet get started writing Ruby, get started writing extensions is in Factor because it's super simple. And we're actually in the process right now, it should be hopefully this quarter, we already have a C++ version of Factor that we've rewritten Factor from scratch. Feels and looks almost exactly the same with a couple of key features that are different. The biggest difference is it's a ton faster. In a lot of cases, it's up to 90% faster. So somebody ran some tests and they were showing it taking, oh gosh, I think it was 10 seconds to run the Ruby Factor, which is painfully slow, and it was taking a third of a second to run the C++ version of Factor. So but if you've got Factor plugins today, they all work just fine. They work, even if you've got Ruby plugins, they work exactly the same. So we're in the process of, on the client side, migrating over time really all of our code from Ruby, where it's slow and hard to maintain and hard to test and has lots of security vulnerabilities, to, in general, C++, because you get the easier to distribute, static binaries, things like that. So Factor is the first place we're starting that. If for those of you who have written plugins, I recommend you go check out the C Factor repository on our GitHub repository. Once you have once you have these modules in place, once you've built these modules to say, hey, here's how the world works, here's the state that I want my systems to be in, you go through this classification process of, for all the nodes in your infrastructure, talking about what roles you have, what roles is this host supposed to provide? Is it production? Is it development? And one of the keys of classification in Puppet is it's aspect-oriented, meaning you don't have to separately define what a production web server looks like. So you might have a production web server running in London and a development web server running in Atlanta, and the fact that it's in London is going to result in some configuration changes, right? You've got a different IP space, you might have a different DNS server, you might have multiple different configurations that are London specific, but aren't really web server specific. And so an important part of the classification in Puppet is when you intersect these configurations, you want to make sure that as much as possible, you don't have to tie configurations that aren't otherwise related, right? If your IP space isn't relevant for your web server, then you want to be able to have these separates. When you go about classifying, you can say, the people who care about what it means to be production can be separate from the people who care about managing IP, right? Your network people don't have to worry about the difference between production and development. I talked a little bit about Factor already. And there's a very real chance I'm going to finish much earlier than I was supposed to. Factor knows way more about your machines than you would generally. It's quite surprising how much it does know. I was pleasantly surprised to find that the first 9 pieces of information are actually useful. The 10th one, it turns out, was a list of interfaces, which was much longer, so I cut it off. But Factor knows a ton about every machine in your network, and this ends up being pretty useful because if you're using Puppet, at least if you're using Puppet with PuppetDB or really any of the central server stuff, you get a complete list, not just of all the machines you're managing, but of all of this additional data. You get all the kernel revs, you get all the kernel versions, all the operating systems versions. You have a ton of information about all of the machines in your infrastructure, which ends up being a very powerful way to really just keep track of what's going on. I still run into companies today who have a spreadsheet with all the servers in their infrastructure listed in that spreadsheet. I was talking to somebody in Barcelona this week, and they have, what was it? They have 4,000 or 5,000 machines. They're adding 1,000. Now, this was a company who was adding 1,000 VMs a month, and they add all the VMs manually, and they have a person whose job it is to update the spreadsheet when they add those 1,000 machines a month. Right? This doesn't work very well, and by it doesn't work very well, what I mean is you should expect your entire world to catch on fire if you try this. And so when you're using Factor, when you're using Puppet, you get this automatically maintained list of that equivalent of that spreadsheet. And the nice thing is it's all in a nice database. You can do queries against it. You can dump it. You can modify it. It's got a good API, things like that. Is anybody here using R10K today? All right. So my guess is, so you should all look at R10K. R10K is it's a very simple, it's a relatively simple, but a powerful tool. The idea behind R10K is it helps you manage the flow of change through your environments. So hopefully, who here only has a production environment? Who here doesn't have like at least or maybe I should ask it the other way. Who here has at least 2 environments that they're using that they migrate change through? At least 2. All right. Just for fun, who's happy with the process they use for migrating change through their environments? All right, a couple. Good. Not nearly as many who are using them. So R10K is a very simple tool. Essentially, its job is to both deploy the Puppet modules you have to your individual masters, but specifically to do it in a way that takes advantage of environments. So if you're looking at, look, I want to push change from my laptop into a test environment, maybe into a UAT environment, and then into a production environment, R10K is a great way to do that. It's a very small, very simple tool written by one of our developers, and we're in the process of, it's actually been being widely deployed by our services team for a very long time, and we're in the process of getting that kind of more wired fully into the Puppet infrastructure. And pretty soon it's going to be in Puppet Enterprise, I believe. We've also got Razor, which is a hardware provisioning tool that is mostly maintained by David Ludercourt, who is in the back here, and who he just happens to be from this country, which doesn't really affect Razor per se, although I don't know, maybe I know I tended to cuss in the comments in my code, so maybe he cusses in German in the comments of Razor, I'm not sure. But the idea behind Razor was, I mean, obviously there are a bunch of provisioning tools out there. I guess Jumpstart still does exist, but there's Kickstart, there are a lot of other tools out there, but we got a lot of demand for, first, a provisioning tool that was cross-platform. So you could provision Red Hat machines, Debian machines, Windows machines, and really just about anything else. And then second, that was faster and better aligned with how people actually use their infrastructure today. People were saying it felt awkward to be, I can turn on a VM or I can turn on an AWS machine really, really quickly, and it's got this really dynamic, really nice interface. But when I go to do a physical machine, it's a really clumsy, clunky environment. So the idea behind Razor was, how can we build a cloud-like physical provisioning tool? We've got a very simple, but it's not simple actually. We've got a very powerful command and control tool called MCollective. And MCollective it's built on ActiveMQ. So you can use MCollective to broadly query your environment, try to figure out, so you find, anybody still dealing with all the security vulnerabilities from this week? It was this week, right? Poodle was this week, and then there was all the 7,800 Java vulnerabilities that Oracle announced. I'm exaggerating a little bit, but it's not by too much. So a lot of our customers, when these things come out, they use MCollective to go figure out, okay, who's got this version of this package installed? Who needs to have the software update applied? And then either maybe go through Puppet, or depending on the urgency, they might go through MCollective directly and say, all right, actually go update this package right now. You put the update in your Yum repository, use MCO to run right then, update everybody right away. So the idea behind MCO is it's a good balance with Puppet, because Puppet is a very declarative and not really a very interactive tool, right? In general, with Puppet, you're focusing more on the code, you're focusing on the development experience, you're not really focused on the interactive aspects of Puppet. MCO is a very interactive tool. The idea is it's going to be the most powerful interactive interface to your infrastructure. And if you're using Puppet today, hopefully you're using PuppetDB. Certainly if you're using Puppet Enterprise, you're using it. And PuppetDB really knows nearly everything about your infrastructure. It knows every host you're managing. It knows every resource you're managing all across your infrastructure. It knows all the dependencies between those resources, and it knows all the changes that have ever happened to any of those resources. So all of the applications we build, almost all of them are built on PuppetDB. Almost all of them rely heavily on the data that's in there. And there are a lot of community applications like Puppet Board and I think Puppet Explorer that are also built against it. So there's a lot of data in there, and this is really, I think, one of the great strengths of Puppet is how much we know about your infrastructure, and as a result, how much more we enable you to do. We also have this one's hard to explain. Everyone who uses Hiera knows exactly what it's for and really likes it, but it's kind of hard to explain why it's there otherwise. When you're building Puppet modules and you want to build a reusable module and you want to have a lot of details about your organization, let's say you've got an IP space or a policy, not a policy, but things like host names, IP spaces that are important for that module to work, but if you include them in the module, they make it not reusable, right? They make it so somebody who doesn't have those same constants, same defaults, it doesn't work for them. So Hiera is a way to extract all that data out of your modules, and your modules can really focus on code. They can focus on the decisions, on the resources, on the things that need to be managed, and then the data goes in Hiera. And when you distribute that module, you distribute it in a way that somebody else can they replace just the data, and they don't have to modify the modules. Because the goal with Puppet is, I want to get to the point where we have modules on the Forge that can cover about 80% of the problems you have. Ideally, almost any problems you have in your infrastructure, if you're not building custom applications, you shouldn't need to build custom management to go with it, right? If you're using Nginx, you shouldn't need to write your own Nginx management. You should be able to use the one that we have on our website. If you're using Passenger or any of those things, you shouldn't have to write custom management to go with it. To succeed at that, you have to find a way of taking the constants that are part of your infrastructure out of your modules and extracting them. So that's what Hiera is really it's about. And again, it's a little bit hard to explain, but if you look at the website, if you look at the software and the documentation on Hiera, it'll be pretty clear what it's for. And then the last piece of the open source infrastructure I wanted to talk about is at PuppetConf, we announced a brand new Puppet server. And this replaces the need for a separate web server, and we traditionally something like Nginx and Passenger would be our front end for Puppet, and this replaces the need for all that. Now you just have a single front end service, and the agents talk directly to that. And there are a bunch of really awesome things about it. So we actually rewrote a lot of that core front end in Clojure instead of being in Ruby. For one, it's just a much simpler service, right? This is one service you have to maintain instead of 3, which is always good. It's also a ton faster. We've found it's between 2 and 3x faster than the Ruby server. And so, and again, this is just the first version, so there's a lot of really interesting things to come with this. And part of the point with that and the discussion of C-factor is to kind of talk about, Puppet's been around for a long time. I first released the 0.9 release, I think, in right around this time in 2005. So it's been 9 years, but still we're making some pretty significant changes all the time. So this is the overall world. We've got this very powerful and relatively can be complex central infrastructure where you've got a lot of different software packages that are necessary to make this whole thing work. Puppet itself, portions of Puppet are all very simple, but the reality of modern infrastructure, the reality of what it takes to really build and manage all of your infrastructure, and beyond that, the reality of it's not just about Puppet, right? You've got to have version control, you've got to have testing, you're often using something like Jenkins. You've got to have a more complete view of the world. To get that, you do end up with a lot of complexity. And if you want things like PuppetDB, you want all the data about what's happening in your infrastructure, you end up with a pretty big system. So we're a software company, Puppet Labs. We don't, we write a lot of open source software. A lot of what we do is today open source, but we make almost all of our money selling software. And when I started the company, that was my goal. It turns out, I don't know why, but engineers nearly always refuse to work unless you pay them. And I figured the best way to pay engineers was to have software that I could sell. So when they make software and then I sell it to people, then I can use the money that I make from doing that to pay the engineers. And the open source we build is a really important part of what we're trying to do. I think it's important that I would like to get to the point where nearly everybody uses the same core engines for a lot of their work, right? It's annoying and expensive to have 5 ways of doing things, right? It's annoying and expensive to have every company out there having to integrate with multiple different products. So one of my goals with Puppet is to have it be as ubiquitous as possible, so you can always just depend on it being there, right? You can just expect wherever I go, Puppet will be there. That will make your life easier. It'll make the other software companies you work with, it'll make their lives easier. And being open source is an important part of that, right? We would never have gotten distributed in RHEL. We would never have been part of Ubuntu with Debian all those years ago if we weren't open source. And so the open source really is important to what we're trying to do. And certainly my whole career, right, I've been working on open source. And so it's always meant a lot to me. But there's a lot more we can do beyond that, right? If you look at a lot of what we will tend to, when we build commercial software, it's nearly always going to be the stuff that sits on the server. It takes advantage of all that data that's in PuppetDB, for example, building new applications. So at PuppetConf 3 weeks ago-ish in San Francisco, we announced a new commercial node classifier, which we're calling Puppet Node Manager. And one of the great things about this node manager, and this is, it's a pretty simplistic release. It's it's going to get a lot better. We're going to do a lot of interesting things pretty quickly. But the core of the product is a rules-based classifier. Instead of going in and saying, I want this node to be this or I want that node to be that, the idea is you take all the factor data you already have, right? You've got nodes checking in. You know everything about these nodes in the first place. So rather than talking about individual nodes, you just say, look, anybody who comes in who looks roughly like this, that means they're a web server. If they look like that, that means they're a database server. It's a bit like smart playlists in iTunes or something like that. Rather than manually building your lists and groups, just have all the things happen automatically. And one of the main goals here is you bring a new machine up, you shouldn't have to go in and classify anything about that machine. You shouldn't have to go in and say, hey, specifically, I brought up a web server, or I specifically brought up a database server, because you've got all your rules in place. The system can automatically detect what that server should be, go do the configurations for you. So moving more and more to a world where you don't have to mess with things to make it all happen, right? It should all just happen automatically for you. Another thing that we showed at PuppetConf was new reporting services. So the new Puppet server, we built a plugin for it that keeps track of a huge amount of things going on. So it keeps track of every function call. It keeps track of every call overall. Keeps track of every API call. And we built a simple Grafana dashboard, and it's Grafana's built on Graphite, and that basically just shows you all this data, right? So a simple way of saying what's going on in my infrastructure. For small groups, this might not be very, very powerful, but for large organizations who have 5 Puppet masters managing 10, 20, 30, 40,000 servers, you start to kind of wonder, or even 500 servers in a lot of cases, as you start to run into scaling issues, you have to, it can be tough in the old Puppet system to figure out what is the actual problem I'm trying to solve, right? Why is it so slow? So we had one customer who had written a function that essentially the function was taking 20 seconds, 30 seconds. It was longer than that. They had done something that was recursively calling YAML parsing, and YAML is incredibly slow and also insecure. But in this case, it wasn't the security thing, it was the slow thing. And they called us and they said, well, Puppet is so darn slow, I'm going to have to stop using it. And so we went and tried to figure out what the problem was, and it turns out that they had this one little function that they had written that just took forever, and that's why it was all being slow. So we had another example where a customer was recursively managing like 340,000 files on 2,000 machines, and every time they did that, it was uploading a piece of it was uploading status information on all 300,000 files to PuppetDB, and they were pretty upset because PuppetDB was growing very quickly. Well, this is okay. Well, let's understand what's going on in your infrastructure. How much capacity do you have? Is it enough capacity right now? If it's going slowly, why is it going slowly? So the idea behind this is we want to give you a basic operational console that tells you, here's how your actual Puppet infrastructure is working, and here's where you might need to look at improving it over time. And then lastly, we've got a nice reporting interface that helps you essentially dissect what's going on in your system on a couple different dimensions. So rather than just saying, here's an individual node, or here's the entire infrastructure, which is how reporting is tended to work, we've got what I think is called Event Inspector inside Puppet Enterprise that helps you understand, let me look at all the changes in my infrastructure by class, right? Look at all the web servers, look at all the database servers, look at, if I'm seeing changes, where are those changes happening? You can also look at them by node, so if you do want to look at an individual node, or you can look at it by resource. And it ended up being a really interesting picture because when you get a failure or when you see a change, there are cases where it looks like that change is pervasive, right? Every single machine in my infrastructure is failing. Okay, but if it's only one file and it's a failure to update MOTD file, that's probably not that critical of a change. Whereas there are other cases where, a single class is actually entirely broken, but it's affecting almost nobody. It just happens to only be affecting, your core database servers. So it's a powerful way basically to figure out when something is happening, how wide is that scope, right? How broadly scoped is the change that's happening? And when there's a failure, again, how broadly scoped is that failure? So what does this mean for people, right? What is this ability to make change? What does this ability to automate portions of your infrastructure mean to you as a user? I mentioned this a little bit earlier. One of the challenges when we wrote the DevOps report was, or when we were doing the survey, was how do you decide if somebody's doing DevOps, right? How do you decide if somebody's doing real DevOps? And we tried to not have to answer that question by basically saying, what are the practices you have in your organization, right? Rather than saying, do you think you're DevOps, or do you think X is DevOps, or do you think Y? We basically tried not to talk about the labels per se and just said, hey, how often do you deploy? What tools do you use? Do you use continuous delivery? Do you use version control? And some of these are pretty basic, right? My guess is everybody in this room is using version control. If not, you shouldn't be listening to talk about Puppet. You should be going home and learning version control, because that's way more important. Start with the basics. But what are the practices you have today? And then try to understand, and then also how does your organization perform, right? How quickly can you deploy? How often can you deploy? And then try to correlate the practices people have with the behaviors they have. And we found a lot of interesting things. And, and as it says here, one of them is we found that people who have a lot of these DevOps-like practices, people who are using automation, people who are using continuous delivery, people who are using version control and things like that, can deploy up to 30 times more frequently. And I think this is a pretty big statement, because when I talk to people about what it takes to move that much more quickly, right? It's certainly not just a technology problem. It's much more than a technology problem. And almost all the companies I talk to, the biggest change that they're having to figure out, it's not just technology, it's a cultural change, right? They have to switch from a company that is more concerned about security and more concerned about stability to a company that really, their primary concern is, how do I move more quickly? How do I recognize, capture, and fix the things that make us move slowly? And in so many cases, it's a combination of technology and culture, right? If you have great automation, but you're afraid to use it, then it doesn't really do any good, right? We have some companies who use Puppet, but they use Puppet to tell them what changes need to happen, and then they go and they manually make those changes on the servers. Okay, well, those companies they don't move very quickly as a result, right? So how do you change how you think about the world, and how do you change your technology at the same time? And what you get is move much more quickly. You get a lot fewer failures in your world, which is pretty fantastic. It's funny how you can, and when I say 50% fewer failures, I don't mean on a given run, I mean totally, right? They're doing 30 times more deployments, and across their entire infrastructure, they're seeing half as many failures. So that's pretty fantastic, right? Imagine if you could reduce the number of pages you get right now by 50%. I bet you do that in a heartbeat. The funny thing we found that we didn't expect to find was that companies who, again, have this set of practices that we consider to be DevOps, in general, there's a pretty strong correlation. We saw a 50% higher market cap for those organizations. People for whom technology was a competitive advantage actually competed very well in the marketplace, which wasn't necessarily obvious. Dice.com recently came out with a survey that showed that Puppet was the fastest growing technology skill in the market, above things like Hadoop, NoSQL. Now this is growth rates, not overall adoption, but still goes to show that people recognize the value of automation. People recognize that this is one of the things that everyone's got to begin adopting. There are a bunch of really interesting companies out there who are, I think, setting various kinds of standards. So Pinterest is, I assume most of you, I don't know, who knows who Pinterest is? I assume everybody knows who Pinterest is. Nobody. All right, Pinterest is not in Germany. Okay, so Pinterest is it's a really stupid sounding site that allows you to save pictures of things you may or may not ever want to buy or see again on the internet. Right, it doesn't sound very interesting. It is very widely used, and it's a website, not surprisingly. They also have iPad and iPhone apps. But the really interesting thing about Pinterest is their usage graph is around breakfast, they get this huge spike, and then around lunchtime, they get a huge spike, and then around dinner time and for the rest of the evening, they get another huge spike. And they've got their automation tuned so that about an hour before their first spike of the day, they start spinning up machines, and then as the spike begins to go down, they can turn them off. And their average server lifetime is about 3 hours. And they have a bunch of really interesting things that match their spend on infrastructure almost perfectly to their user load. And there are a lot of people who don't have that kind of variant workload, but theirs is so variant and the spikes are so large that they save hundreds of thousands of dollars a year. I was talking to them last year, and they said they made this one tuning of just turning off machines a little more quickly. It saved them $300,000 a year as a result of that change, right? So it's a pretty massive difference, and it's because they're that much more dynamic as an organization. CERN is managing more than 100,000 machines with Puppet. It's a sizable infrastructure. They've got a huge amount of data. They've got a huge amount of processing to do of that data. This is all for the Large Hadron Collider that they're building this data center for. So they're a pretty extreme use case. And then Bank of America is another extreme use case. They're one of the world's largest banks. I don't know if they're actually literally the world's, they're a very large bank. They've got 12,000 applications roughly in production, more than 19,000 software developers. They're also one of the world's largest software developers. Who knew that, right? And they had this amazing combination of, in a lot of places, extremely cutting edge, very modern technology that has to update frequently, and they're competing against some of the best technologists in the world. And then on the other end of the spectrum, they've got pieces of software and hardware that haven't been touched in 10 years, and they have to somehow figure out how do we maintain stability? How do we get how do we push the whole company forward without, breaking the law or, causing our customers to all get pissed off. So they're doing a lot of really interesting things. They've got Puppet on about, it's something like 4,000 to 5,000 machines. They've got thousands of machines that they're also managing Puppet. So from here, there are so many places to get involved in the Puppet community. Dawn knows all of them because she, one way or another, is the catcher for so many of them. But obviously, the camps are a great place to get started. We've got a ton of online resources. Our IRC channel, what is it? Is it 900 people these days? More than that? More than 1,000 people on IRC these days. And the mailing lists are also thousands of people on the users list. The dev list is very interactive, lots of discussion about how Puppet is changing, what is changing. We're doing a lot of Puppet 4 is going to be coming out very soon, and you're going to see some of the largest set of changes to the language in Puppet 4 that we've ever done in any release. And a ton of those language changes have been being discussed really in depth on the Puppet dev list. So if you're interested in how the language is going to evolve over time, well, at this point, most of them we've already decided, so you have to go look at the archives. But yeah, you can also get involved for the next generation of changes we're going to be doing. If you want to come help with bug triage, we would love to have you help us. People are always submitting bugs, and we're always looking for help in, is this a real bug? Can we reproduce it? If we can reproduce it, in what circumstances? And then, hey, submit a pull request. Come help us make the product better. We've got a ton of training classes, and we now have, including yeah, I'm supposed to not go switch. Yeah, anyway, we've also got a lot of online trainings. We just launched this about 1.5 years ago. We've got short, kind of 5-minute courses that go from the very simple stuff to relatively complex things. And we're trying to find a way to encapsulate a lot of the core problems of what people have to learn to use Puppet into these short videos, short training classes. You can also go download the Learning VM, and the VM has a we kind of talk about a quest log, a set of tasks that you have to take that walk you through kind of a lot of the key tasks of interacting with Puppet. And that's a great way to learn more about the product and more about what the product can do. And then finally, come help us make the product better. We spend a lot of time doing various kinds of user experience research. We've got some new product we're trying to build, and so we want to see, hey, is this actually any good? Or conversely, we'd like to just kind of sit over your shoulder, either virtually or physically, and watch you use pieces of the software. I'm a big fan. When I first started the company, I would do all the services because I was also the marketing guy and the engineer and the salesperson and the everything else. But my rule when I did services was I wouldn't touch the keyboard, and that wasn't just because I'm lazy and have a fear of other people's germs, but also because it allowed me to watch other people use my software all the time. And it's really valuable to see you attempt to solve a problem with something, right? Because we think it works perfectly, right? We think there are no bugs and it's easy to understand, but you might not find that that this particular interface works. So the Puppet Test Pilots program is a great way for us to understand what parts of the software are working for you and what parts of the software aren't working for you. And then lastly, for all of that, we've been working on this for a very long time. For all that, I think this is, again, I think it's an exciting time. I think that there's more interesting stuff happening in infrastructure than at any time since I've been involved. At the same time, I really feel like we're very early in the process of building interesting infrastructure. I think that you look at how the silicon, the transistor revolution, we're only about 40, 50 years into transistors overall. Maybe it's a little bit more than that. Integrated circuits, about that age. But software, right? Software as an industry and software as the major thing that we do, right? The thing that so many of us are involved at some level in software production. And it's taken manufacturing. Manufacturing has been working on optimizing manufacturing for more than 100 years. And there are still constant, lots and lots of improvements in how people do manufacturing. So for me, the world of how you build and maintain software, how you build and maintain infrastructure, we've got a solid 50 to 100 years, and I think it's closer to 100 years of heavy optimization and heavy learning to do before we start running out of really difficult, really interesting problems to work on. And I have people all the time come say things like, well, Luke, what's going to happen when nobody owns servers anymore? Or what's going to happen when Docker makes all configuration management completely irrelevant because everything's immutable? Or things like that. And the reality is, like, there's just so much left to do. There's so much complexity left to solve that I know a lot of people feel like they're getting to automation late, or oh, we're all behind. But I tell you, there's so much more interesting things left to do. Really, just finding any way to get involved, I think, is a great place to get started. So that's it. Thank you. And I think we have 10-ish minutes for questions. I don't know if there's mics in the back, or I'll just repeat your question. So if you have any questions, I'll just repeat the question. That way we can have it on camera too. Any questions? Hey. Question. The question is, will MCollective move to JVM like other things? We're right now in the process of figuring out what MCO.next is going to look like. We know that it's unlikely that the client-side pieces of MCollective, I don't think any of the things that are going to be installed on the agent in general will be on the JVM. I think in general, everything on the agent will either stay in Ruby or it'll be moved to an easier to maintain agent-side runtime like C++. And so the server side, maybe, but we're just now figuring that out for MCollective. Anything else?
Why do you write the server in Java and the factor in C++ and not do both in the same language?
So the server is actually in Clojure. It's on the JVM, but it's in Clojure, which is a Lisp dialect that runs on the JVM. I think the easiest answer is because we can. And it's nice to be able to say, because the client side and the server side, they have different problems, right? There are different things you want to optimize for. On the client side, we want to optimize for ease of distribution, ease of adoption, ease of upgrading, and the ability, and frankly, interactive experience, right? When you run a command, you want that command to run right away. You want it to respond immediately. You don't want the 700th command to respond immediately, right? You want the first one to respond immediately. And we see this with, but on the JVM, the concerns are different. The concerns are, is it reliable? Is it very stable? Can I deeply introspect what's happening, so if there's a problem, I can really understand the problem, right? What kind of tooling is available to help me make sure that the server side has a highly reliable runtime, and then how well does it scale, things like that. So we have different priorities, and the nice thing is because they're all pretty well decoupled through their APIs, we can essentially build different runtimes, and it's gonna be interesting, right? And PuppetDB was our first Clojure project, and that was about 2 years ago. Factor's our first C++ project. So it'll be interesting to see how the teams shift over time, because they're going to have to kind of get further apart. I think it'll actually be good, because it'll mean that our APIs get better, right? Because these teams, their only way of communication is going to be via the API. So I think it'll make the system overall more stable and reliable. But yeah, that's our motivation. Question?
Hi, will the node manager be only available within the enterprise products, or will it be open source?
It will only be available in the enterprise product.
So this is a question more regarding integration with clouds. So let's say public clouds or the private clouds. So as of now, most of the deployments that I have personally heard about, it's about getting the instances up and then running some kind of upstart scripts to bootstrap Puppet. So is there something in pipeline, or is there something already there so that we can streamline this process of getting instances up and bootstrapping them with Puppet without using some kind of a user script or something?
Yeah, I think it's actually already gotten a lot better. I don't know. I know on Puppet Enterprise we have, I think they call it a frictionless agent, where basically you can set up the AMI's start script. I don't remember what it is, the startup payload, or I don't remember what the term is, so that whatever Amazon runs for you when the machine starts up, that'll get Puppet installed, configured, and zero interaction, just come up and do everything. You don't have to do anything else. There's also been a lot of work. I'm hesitating because I don't know the exact state it's in. So Gareth Rushgrove joined us a couple of months ago, and previously he was at the UK government, and he did a ton of work in exactly this area, and he was able to open source all that work before he left the government. And so there are kind of 3 or 4 different efforts that involve connecting Puppet to various clouds. One of his main jobs is, let's get that down to one effort. Let's have one clear, common, great way of doing things. I just don't know exactly where he is in that process. So I know there are multiple good things you can do right now, and there are probably multiple not very good things. I think that it's actually pretty streamlined, but if you find Gareth, I think he's Gareth R on the Twitters, but I know he's on the mailing list in IRC too. So he's probably the best person to ask about specifically, but I think there are good ways to do it, and maybe we just haven't done a good job of putting it in front of you.
So yeah, actually, just to make it more specific, I'll just name a couple of other tools and the things that they use. So in Chef, the things that we know as Knife, and in Salt that we know as Salt Cloud. So what they do is they have some kind of a map file, and you can go ahead and communicate with any of your clouds. Let's say public cloud, OpenStack, CloudStack.
Yep.
So what happens is when you run those tools, what it does is goes ahead and fetches your AMIs and does your stuff, everything. It bootstraps the client and it communicates with the server. So what I'm looking for is exactly something similar.
Yeah, and I know Gareth's goal is to have something that's at least as good as what anybody else has, and if not better. So I just don't know exactly where we are on that plan.
Sure, thank you.
And just going back to your question about whether the node manager is going to be commercial or not, and then I'll say this and then I'll be done. It's a funny situation. So we had a bunch of people at PuppetConf, and it's something that Puppet Enterprise has been around for about 3.5 years, and for most of its life, it's essentially focused on being a simple to upgrade, simple to maintain distribution of Puppet. So take all of our open source software, build a distribution of it with a small amount of commercial functionality, but not really that much. And we're shifting strategy a bit, and we're focusing the commercial software efforts on essentially separate applications that sit on top of the core Puppet platform. And these are applications that you don't have to use, but if you use them, then we think they'll make your experience better overall. And it's been interesting because it became clear how much neither we as a company nor our community is used to us having commercial software that the community would like to buy, because people get really upset and they're like, well, I want to use that. It's like, well, yeah, that was our goal. We wanted to build software you want. Yes, but I will have to pay for it if I use it. Yes, that was our goal too, was to build software that you wanted to use and had to pay for as a result. And so, yeah, it's going to be an interesting transition of, having, again, as the person who's running the software company, it's all about how do you find the right balance between, I want to make sure that all of our software is great. I never want to build a business that requires our open source software be crappy so that our commercial software can be great. But I also want to have a good enough, compelling enough commercial product that I can pay my engineers. And I have to be able to pay the open source engineers too. I can't just pay the commercial software engineers. So it's going to be an interesting couple of years as we figure out kind of how to redraw the lines. But I think it'll work out pretty well. So thank you very much. I hope you have a great day at PuppetCamp.